Gentlemen, I give you the Yaesu Fl 7000. Okay, let's start from the top down. This is 160 through 15 meter amplifier. They claim on paper that this thing can do 1200 watts. Me personally, knowing that, you know, it's got the MRF 448 50 volt bipolar transistors in it at 250 watts a piece, that's asking a lot, and there's 4 of them in this thing. There's 2 here and there's 2 here. We're going to cover all of that here in a minute. This has also got an internal tuner in the amplifier, which I always feel is a bad idea. There's a lot of ham guys that think that this is a great idea. At least for this amplifier, it's a bad idea in my opinion. Just in my opinion. The thing that makes this really cool is that it utilizes heat pipe technology. Now, you guys can see the other camera here. We're going to jump over to that here in just a second. I'm just shooting the intro for this. This is an automatic tune. It's got internal antenna switches. It's got a cool, straight out of the 80s cassette deck LED display on the front of it, which is kind of disgusting to me because some of the most expensive stuff that we can still buy here 40 years later, like some of the alpha amplifiers and so forth, have got LED displays on the front. It's like, come on, man. I got a phone call coming in. Come on, we got this thing over here. It's, how hard is it to put a friggin' display in? Anyhow, I digress. And I always wondered why amateur radio is so far behind the cell phone technology as far as integrating stuff and interfaces and whatnot, but it's coming along. Let me switch over to the other camera. We're going to fly around this thing. We're going to look at it. We're going to check out a bunch of stuff. Give me just a second. The reason I wanted to jump over to this camera is because it's got amazing image stabilization. This camera is what made this channel famous. I've shot so many YouTube videos with this little guy. It's scary. Love this little camera. Okay, so over here, this is our primary access for us to change ourselves from 110 volt to 220 volt. If you're running 110, you're going to look at the upper portion of this chart, like that. If you want to run 220, you look at the bottom portion of this chart. And as we can clearly see, we're obviously wired for 110, which is great for us. Makes it a little bit more flexible. This amplifier has got the best layout plan in it for a modern amp I've seen in a while. Here's our transformer. Of course, it's 2, 0 through 117, 0 through 117. So it's pretty obvious how we're achieving the 220 operation. We're going to take this and tie it to here. So we'll give it 110 here and 110 here, otherwise 220 total. And you tie the phases together, or the primaries, let's say. This is our power supply and voltage regulation unit. Let's go ahead and turn this thing up on its side. Here's our filtering cap bank. And our rectifiers are buried down in that gobbledygook. Once again, here's our secondary outputs of our power supply. This amp is stupid clean as far as like no dust. It was kept in a non-smoking environment. It's got a committed one-way fan for just the power supply section. And I've got all the case pieces and armor and lids and all that stuff off. This is truly isolated from the RF deck and the tuner. This is the cooling for the amplification side. And this is why this is so important to me. This thing, the way this thing cools itself, to me, is impressive. So here's the top side of our tuner, which is very slow. The servos and the mechanisms that run this tuner they're slow, but it works. This tuner actually works really well. The problem is when you go to operate it, you're sitting there on the key, holding it down, waiting for the step motors to go meow, 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 meow. Very, very slow. Very, very slow. And as this thing is doing its job, the finals over here are having to deal with a huge amount of change in output, right? So they're seeing something like a VSSWR of like maybe, you know, let's say a 1.2, and then all of a sudden, as the tuner's doing its thing, jump up and jump back down, and it'll go up to 9 and down to 7. And every single review I can find on this amplifier clearly states, unequivocally states, that you want to use an external tuner. Just leave this thing in bypass, because the main thing that's going to cause this thing to go out is trying to tune with a high output power. So if you're only wanting to generate a small carrier level when you first tune, that's one thing, but that's not how most hams operate. They're, you know, you got the thing dialed up 800 watts and they're going to tune at that power level. This is our output filtering board, which is really super tiny, compact, and cool. But the reason I think that this thing is so neat is because of this technology. That is a cooling pipe. This makes it unique, at least to me in my world. Let me explain to you why. It's been so long since I used this camera. It's nice to be able to move stuff around and automatically have my white game balance set up for me. Cooling pipe tech is cool. It's really, really neat. So a cooling pipe, all it is, and cooling pipe techs is really efficient in getting rid of heat. I normally think a cooling pipe tech is something that's really been taken onto with the computer industry, gaming industry, as in far like PlayStation, Xbox, that kind of thing. It's a way to be able to very efficiently move heat from A to B and spread it out over a large surface area. Heating pipe, if you really want to know the minutia of heating pipes, there's a lot of YouTube videos out there, but you'll find that most heating pipes are a vacuum with a liquid inside of them. Now, the inside of the heating pipe has got powdered aluminum or some other form of powder silicate on the inside of it, and it's impregnated to the walls of the tube. Well, inside this tube we have a vacuum, and then they insert a gas. Most of the time it's a water, okay? And we're talking not like, oh, hey, let's crack the pipe open and drain an ounce of water out of it. No, we're talking water in, like if you were to crack the pipe open, the water would evaporate before you could observe it. It's more or less in a gaseous form. The other really common forms of heat transfer media, because that's the way you got to think about it, is nitrogen and ammonia in heating pipes. Now, there's going to be some expert out there that's going to get down in the gobbledygoo, you know, down there in the comments and come along and try to tell me I don't know anything about anything. And you're right, I'm not an expert on heating pipes, nor is it my job to be. I just have to understand the basic fundamentals of how it works so I can work with it or repair it. It's not my job to be an expert on just this one particular thing. This amplifier sets itself apart because for these 4 transistors, it's on a heat sink surface or heat dissipation surface that is literally 4 inch by 4 inch by 4 inch. And it does an amazing job at that. As the moisture in the tube is heated, it turns into a gas which travels up through the tube, and as it dissipates its energy, which has turned it into a gas, it recondenses into a solid, hits the walls of the tube, and then migrates again back down towards the heat point. So it's a closed loop, self-recirculating cooling system. Because it is so good at moving heat from A to B, it allows us to significantly diminish the amount of weight and significantly decrease the footprint of the cooling device. And then on top of that, because there's so much surface area involved, it would be like the equivalent of having like a 6 foot by 6 foot freaking heat, you know, aluminum heat sink. In theory, it'd be huge. It'd be monumentally larger than this. Like the heat sink surface area that is provided to the cooling pipes here would take up this whole flipping amp if we did it in just one solid block of aluminum. Remember, there's certain characteristics of aluminum and there's certain characteristics of heat or copper that lend themselves to working well with each other. Copper is a great radiator. It's also a great sink, otherwise its ability to absorb heat and move it from A to B. Well, aluminum is also right there with copper, but just slightly behind it in its ability to store heat. It has a very, very slight advantage over being able to dissipate heat or being a transfer media, getting rid of it, changing it over to the air. Okay, a little slight advantage there over copper. But copper's advantage is its ability to move, transfer heat from surface to surface. But because it is so close to aluminum, you can compensate for that with maybe like one more aluminum fin. That's why and copper is much denser and it's heavier. So it's a toss-up over weight and ease of machining versus actual heat management. So the best of both worlds is, well, aluminum heatsink with a copper spreader on it, because the copper will absorb the heat and move it across the entire surface area of the aluminum, and then it does a good transfer. Aluminum does a good transfer of absorbing the heat from the copper and then dissipating into the atmosphere. But we're talking very small minutia of measurement between the two. This particular copper spreader, not copper spreader, but heat pipe dissipation unit is all copper, this particular unit. The one that's in the 24-core 4K ripping machine that makes up all these YouTube videos for you guys is a copper tube heating, copper pipe, heat pipe tube system with an aluminum radiator. So it's got like 6 or 8 tubes that come off the surface of the CPU, and it goes up to a huge aluminum heatsink rack. Like I said, this has been really, really adopted in the PC world, the computer world, the gaming world, but this is technology that kind of got left behind a little bit as far as the amateur radio community and the amplifier community goes. Now in the commercial industry, this is something that they've capitalized on quite a bit, but we're not going to get into that. We're here to talk about this. So let's start here. You'll see down in here this white glob of jism here. Well, that's thermal compound on top of the transistor. And there's a diode that goes across that reacts to the heating of the component, and it helps adjust the biasing circuit. You'll see down through here is 2 copper tubes. So we have our primary heat dissipation plate, which is here, and that is what our transistors are attached to. These tubes that run through the heatsink fins are heat pipes. They're a sealed conductive system that constantly are doing this with the moisture that's inside of them. Do I specifically know what's inside of these tubes? I absolutely do not. And there's a lot of different liquid medias that you can put inside these tubes that dramatically change how well they work and how they work, and under what aspects they do work. I would assume that this is most likely some kind of sterilized distilled water in a very, very thin media form. But the inside of these tubes has got usually powdered copper on the inside of it that's impregnated to the walls of the tube to help with convection and to help with the recondensation of the moisture. But there are 2 transistors on this side and 2 transistors on this side. So a total of 1,000 watts, supposed full saturation output power. Me personally, 1,000 watts, I see it. But, you know, according to the internet, this does 1,200 watts. I wouldn't count on it for that much. I really wouldn't. When you start delving into that realm, you're now pushing the components outside their operation value. Now, that being said, the MRF 448s, I believe, are what's in here, if I'm not mistaken. They're about $130, $150 usually after shipping. That's not that expensive in the land of transistors these days. It's really not. We're talking roughly kind of that price for most of the MOSFET components these days. And I mean, hell, in the land of the 12-volt world, that is really expensive if you're using Chinese components, but for legit Japanese or American-made components, that's not too far-fetched. It's really not. Well, I think we've shown everything I wanted to show. The RF shielding on this thing is top-notch. We're going to go ahead, we're going to put this lid on, and we're going to put this lid on, and we're going to go ahead and run it without the lid on it for a few minutes. It's pretty simple construction to get the lid off. You have a series of screws that come down this side that hold the lid in place, another set of screws that come across that hold the lid in place. But to remove the panels, you have to remove these side panels first. And I'm sure these were black anodized or the dark brown anodized of good old Yaesu. They're still holding their color for the most part. And this thing legitimately is in great shape for what it is. But I don't know about you. Let's put some lids on it. Let's run it. So I had it all hooked up and was ready to start running it. I turn it on and this lamp is out. It wasn't just like a month ago. So I get on the old Googler and I start typing up stuff, and I thought I would reach out to, well, the Yaesu Fl 7000 expert. And that one of those guys, very nice gentleman, is N4ATS. His name's Bill. Good guy, super smart. He's repaired a lot of these in his life. I gave him a quick jingle and said, hey man, where can I find this lamp? And he's like, oh man, it's just a standard actual lead freaking grain of wheat, blah, blah, blah. Go type into Google or eBay, Marantz lamp, 12 volt. Because you get a phone book. You're like 10 for like 10 bucks. Okay. So I'm on the phone with them all. I'm in front of the doobly-doo, Marantz amp. Bink, came right up. So, needless to say, we're going to take a pause on this for a hot minute. I'm going to fold it all back together. I've already clicked the buy button. So in 3 to 6 days, I'll have those parts. And we'll slide the face off. We're going to take it directly off. We're not going to jerk, twist, or tilt. We're going to slide it directly straight off. According to Bill's instructions, he did a very thorough walkthrough on exactly how to do the lamp replacement. I dig it, man. I really dig it. And I appreciate him, 1, answering the phone right away, 2, giving me the information I needed right away, and 3, just being polite. So on that note, we're done with this for now. I'll be back to this in a couple days. Well, we're back on the FL 7000 this week. See where I left off was I was giving thanks to the guy that helped me find the light bulbs, which are in this sack. According to his very thorough instruction webpage, that we do not want to twist, turn, torque, rotate, just give it a nice solid jink it forward, and faceplate will come off. The reason we don't want to twist, torque, like none of this, none of this, none of this, just straight off, is because of the LED segments. We will spend hours and hours trying to get everything lined back up again, which I can see that now. That's that. So down underneath here is our elements. He says that I need to slice the tape as if the meters don't fall out on themselves. Just trying not to disturb that gasket as much as possible. Oh, I get it. Okay, I get it. There's a piece of tape here, a piece of tape here, and a piece of tape here. So, he says that we'll spend hours and hours and hours getting the LED elements to align up with the face, and multiple attempts to reinsert face back on hole. So, a piece of tape here, piece of tape here, piece of tape here, piece of tape here, and then the face will just pop off of this thing. And then there's a tiny little actual lead grain of wheat light bulb that's down in there. So let me get the tools for that, and when we come back, the meters will be disassembled. So tape has been cut. Soldering iron is heated up. Now, there's somebody out there that's a rocket scientist, and they're watching me right now, and they're going, well, why are you replacing this lamp? It's the good one. And I would say, yes, I totally agree with you. Right now I'm trying to slide this jacket off. Totally agree with you. It is the good one. Guess what? It's the same age as this one that's burned out. So if I got it all apart, and I'm here, and I've got the parts, that's the wrong tool too. Why not take the time and do both of them? That way we get another 20 years out of the thing, right? According to him, this lamp should just slide right out of this silicone booty. And it does not want to move. And I don't want to rip it. So cat came out. Okay. So that's one done. Now let's do this other one. Okay. Oh, this one's been repaired before. Wow, look at that. The previous repair didn't even bother to cut the leads off the bulb. Okay. Easy now. Easy now. Come on. Come on, little girl. You want to come off there? I know you do. Here we go. Why wouldn't you cut the leads off? It's just laziness. Oh well. Ah, come here. Just hang tight there for a second. There you go. Okay. Here we go. Do. Go. Easy peasy. So there's a little kiss of smudge inside the meter, right up the middle of the meter where everybody's going to see it. Still there. Come on. A little kiss of smudge right there. A little kiss of smudge right there. Okay. Yeah, da 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 da. Nope, nope, hey, nope. Let's make sure we didn't bump any of the LED segments too awful bad. None of the switches got any schmoo around them, so I think I'm free to put the faceplate back on. So make sure there's no smudge on the inside of the glass. It's on the outside. Go. Lined, aligned. This tuner lamp is not looking so right to me. Yeah, no, it's not right. I'd take you guys off camera so I could see what the hell wasn't lining up, and I was focused on the LEDs. But what it ended up being was this meter on the end here was not setting far enough that way and down. So I just reached in there with a dental pick, hooked around this side of the lamp, and gave it a slight little tug and pressed down and went click, and it dropped right into place. So beautiful. Beautiful. Well, so I spent half of this damn video bragging about heat pipes and how badass they are. You know, how they're going to make Jesus come back and stuff. So I think it's time that we stop talking about it. And let's unleash this beast. What do you guys think? Gotta at least have the bottom plate on it so the front end can get lifted up for our fan for our RF deck. It's kind of cool that air gets pulled in from the bottom and goes out through the top like it's supposed to, you know, not pulling in from the top and exhausting out the bottom, but hey, what do I know? Hot air does rise, y'all. Then we got the other fan on the other side, which pulls cool air in from the back, and it forces it out the bottom. A little bit of possible cross ventilation going on there, but all in all, this is a really cool design amp. I want to say one more time before we move away from this little segment of video. Big shout out to Bill, N4AT RTS. He's got a very, very informative web page on this amplifier. He's fixed over 1,000 of these at this point. And, well, I can tell you from firsthand experience that you fix more than a few hundred of one thing, you get to know it pretty good. And he immediately pointed me in the right direction, immediately picked up the phone, was very helpful, and I strongly suggest that maybe you go look at his webpage if you have any questions about this amp or how it operates or how to go about maintaining it or any of that stuff. I'd give old Bill a look up. Good guy. I just think this is funny. That's the aftermarket lamp. Here's the stock lamp. Why wouldn't you cut the leads? Why would you leave them behind the lamp or behind the lens? It doesn't. Just laziness. Just laziness. Let's get the radio set up. Sideband. Okay. Let's take a look at our power meter here on the front. We're looking at this top bar. Okay. 800 watts max. And they are serious about that 800 watts max. This is about a 500 watt unit, half kilowatt, pretty reliably piece of equipment. This amplifier was designed to be used with the FT 980. Well, there's a specific communication port that goes between the radio and this amplifier. ACC1 is the port. Well, there's also a specific antenna interface device called the FAST, FAS-1-4R. It's a 4-port antenna segment device. And that's what allows us to utilize this section of the amplifier. This is the manual tune operation of the amplifier because this amp does have a tuner in it. And I believe the goal was that you could buy the radio, buy the unit, buy the antenna setup, and you could have 4 different long wires for all the different bands that you're going to operate, or different, like let's say you wanted to do 10 and 15 and so on, have that on a trap antenna like a butternut or something, or a Cushcraft. You could pre-program all that in here. Pre-program all that and say, when we're on antenna 4, we're going to be operating these bands, and antenna 3 is going to be these bands, and 2 is going to be this band. And the tuner inside can keep track of what you're doing, and you're going to use this as your relative power meter. Hence the reason that we've got a built-in SWR bridge. Okay? We're going to leave it on power for today. We're not going to depress the tuner button. I strongly suggest that the tuner inside of this amplifier is very slow. And in playing with it, throwing just little AM carriers into a dummy load, the tuner is a lot of and you can sit there and watch your power output do this. Well, meanwhile, the FETs that are in this thing are just taking a hell of a punishment. So every review I've ever seen of this, for the most part, states that this amplifier, its tuner, is not the greatest in the world. Just putting it out there. So for today's sake, we're going to utilize our band up and down buttons. We're going to do this in manual, not in auto. We're going to leave the tuner button out, even though when we go to switch bands, you'll hear the tuner adjust. The tuner will adjust and do something in there and make itself happy. Don't care. We're good. According to this gauge, hit 0 and 2. We're going to put 45 watts worth of drive into it. 55 watts, it trips. When the unit goes into protection mode, you have to shut it off, count to 3, turn it back on. And that will reset the amplifier, reset the tuner, and reset the protection circuits. Yeah. Okay. So, we don't have to come back to it again. These are our units of measure. This is a 1,000 watt slug in average, 1,000 watt slug in peak, 1,000 in average, 5 watt slug in reverse back from the Bird 10,000 watt numbing load. Although that this element here, if we can clearly see, is 25 through 40 megahertz or 60 megahertz. So we're not going to get a lot of data out of that until we get up towards the upper bands. And we're going to use our ICOM 7300 here today. So please note, we're at 65% power. Please note, we're running this on a 12 volt setup at the moment. So, long story short, we're going to put about 45 watts in it. It's going to be happy with that. Let's see if I can get the manual or the... There. Okay, let's set this to manual. Now they're roughly both in focus-ish. Okay. We're step on the pedal. Now we're in operation mode. We're going to keep an eye on this one here and this one here. So this is power supply temp warning. This is our weight indicator. This is our warning. This is protection mode indicator, fan 1 and fan 2. Right now the amplifier is not doing anything. The fans aren't running. It's not making any kind of shmoo. It's just sitting here. This light comes on, and this light comes on and tells us that we're in operate mode. We're in send over here, and this one's telling us that we're in operate. Hello, 1 2 1 2, 1 2 1 2 1 2. Now, over here, it's showing that we're making about 600 watts of power. Hello, 1 2 1 2 1 2 1 2. Okay. But down here on the face of this bad mamma jamma. Hello, 1 2 1 2 1 2. Showing us an average, I think. What is odd is when we push it up there towards the 700-800 watts in the peak mode over here, this thing trips. I'll show you what I mean. Hello. As soon as I got the radio to 100%, hello, 1 2. We went into protection mode. Shut that off. Count to 3. We'll dial this back down to about 70-65%. Turn the amplifier back on. Hello, 1 2 1 2 1 2 1 2 1 2. It's my buddy Rodan calling me so he can tell me what his schedule is. I'll call you back, my man. Phone was ringing there for a second. So now we see fan 1 and fan 2 are on. So the RF deck supply fan is on and the power supply fan is now on. Let's go ahead and we'll change bands. It's going up here to 80. We'll wait for it to do its thing. We got green light, came back on. Hello, 1 2. Okay. The exact same amount of drive. Hello. 750 watts on 80 meters. It will do this all day long. Hello. Now we're deep into the red. We're flirting with the protection circuit. We're flirting with it. Okay, let's go on up. 40. Hello, 1 2 1 2 1 2. Let's go on up. 10 megahertz there. Hello, 1 2. 700 watts over here. 500 watts indicated here. Let's go to 20. Ready, lights good to go. Hello, 1, 2, 1, 2. Beautiful. It's going up to 18 megahertz. Hello, 1, 2, 1, 2. We're waiting. Not waiting anymore. Hello, 1, 2. Hello, 1, 2. Just short of 500 watts, but happy. Let's go to 21. Hello, 1, 2. Hello. Oh, I'm on AM. Sideband mode. Hello, 1, 2, 1, 2. Hello, 1, 2. Hello, 1, 2. Easy peasy, cotton peasy. 24.9. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2. Last stop, 28 megahertz. I'm not going to even bother trying to try this on 10 or 11 meters. It would require me changing radios and a bunch of stuff. It's not worth it. This ICOM here on the bench is not Mars modded. It only will work within band. And I have it set up that way for a reason. Hello, 1, 2. Then I'm in AM. Let's go to sideband. Hello, 1, 2, 1, 2, 1, 2. 1, 2. So showing me 600 watts here and about 500 watts here. See what the SWR bridge says. Hello, 1, 2, audio. Obviously, we're going into a dummy load, ALC circuit. Hello, 1, 2, it's working. Power supply volts. Hello, 1, 2, 1, 2, rock steady. This is our amps out of our power supply. Hello, 1, 2. All buttons, all modes, everything works and fixed and repaired. Got good lights on it. We're golden. Hello, hello, 1, 2, 1, 2, 1, 2. According to the internet. Hello, 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 audio. Nope, just went into fault. This amplifier is 1200 watt capable. It might be with this operating radio. Or there could be something here, I don't know what I'm setting up for, but hello. Yeah. I've seen peaks of 950 to 1,000 out of this. But not a lot more than that. Let's throw a carrier with AM. Now it's tuning. It's thinking about it. 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 Still tuning. Still tuning. Hello, audio. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Just thinking long and hard here. Hello, audio. Hello, audio. Hello, audio. Hello. Well, the internet can claim what they wish. I'm going to say this is 6 to 1,000 watt linear conservatively speaking. I'm not going to spend any more time totally farting around with it. This thing is in fully operational order, so I'm going to call this a win. The other thing that I find quite shocking is what people are asking for this piece of equipment on the internet. eBay has got several listed right now. There is one listed for $1,900 for parts. Does not work. Parts, $1,900. There's one on there right now that is, it looks like it's stacked in with a bunch of hi-fi equipment, like vintage 1970s, 80s hi-fi equipment. And they're wanting $2,300 for it. And these are untested pieces of equipment. I don't know. I can't jam with that. I feel fairly comfortable only asking $2,000 for this plus the ride. This thing is pretty good shape. It's pretty rare, so it's going to need to be crated. So you're going to be looking at probably a couple $100, at least $300 in shipping. Just keep that in mind. But that's, you know, plastic bagged, vacuum packed, and then on top of that, the new shipping company has got these 2.5 inch thick pieces of gray packing foam inside of a wood crate. This thing's cute. I like it. But, ladies and gentlemen, Yaesu Fl 7000 solid state no tune amplifier with an antenna tuner in it. All band. Solid state boxes bring a whole lot more for not as much power. Absolutely amazing to me. But on that note, I'm out. Gentlemen, you know how to get a hold of me. First one to call, text, or hit me up there gets it. It's got brand new element light bulbs in it. Since I have no use for these other 3 bulbs that I've got, these other 3 lamps, I'll be sending them along as well, just in case somebody needs them in the future. And if you are watching this trying to get tips and tricks on how to do the repair on your own, yes, I am going to bust out the how to change the lamps into its own YouTube video for you guys to look at as a reference. Just keep in mind that all you got to do is search for Marantz lamp. Okay, Marantz lamp, and you'll find the right light bulbs. So, gentlemen, thank you. Big shout out to all my Patreons. Big shout out to Coaxial Dynamics, Sig, MechMan, Bird, and Coaxial Dynamics, and all you guys. Yay, FL 7000 fixed, repaired, back into the service. Let's go find something else to do. I'll see you guys. Bye-bye.